Hello everyone. Okay, so this is the lab that we would have done in school. It's our first lab for our mechanical energy unit. It's called the Crash Lab. I want to show you the equipment that we're using. This is your science classroom, by the way. So we have our lab tables that are part of the setup. What we have here is a ramp. We have a car that will roll down the ramp. You can see that we have the ramp elevated a little bit. So we have the ramp itself, we have a textbook to serve as our elevation to raise the height of the ramp. What we have when the car comes onto the next table, we have 2 meter sticks. The 2 meter sticks are acting like the racetrack, okay? So we can actually measure the length of the racetrack is 100 centimeters or 1 meter stick. And we are using tape to hold the meter sticks down so that if the car hits the meter stick, it will be able to continue its motion. We made sure that the tape is nice and flat so that it's not causing any bumps in the racetrack or any friction to slow the race car down, okay? Later on in the lab, we will be adding cargo to our car, and the cargo is 500 grams. So 2 metal bars at 250 grams each for a total of 500 grams. So we're gonna do some trials with a car that is empty, has no cargo, and then we will add cargo to the car to be a total of 500 grams.
We also have a parked car. So we'll do the first few trials without the parked car because we want to have a discussion without the car. After that, there's going to be a parked car at the start of the racetrack. So this tape here shows the start of the racetrack. And we are going to be changing the heights and changing the cargo and seeing how far the collision makes our parked car move. So the parked car is another part of this lab. And I think those are all the materials. I also have a piece of paper and a pencil to write down my data, which is very important for us to collect as we do this lab.
Okay, so before we start our actual trials to the Crash Lab, we need to see the effect of how, if we change the height of the ramp, how it's going to change the behavior of the car, right? So we have the ramp elevated 1 book high. Miss B is going to go to the other end of the table to catch the car so it doesn't roll off. These are frictionless cars. You'll see that the wheels are very narrow so that they do not create any kind of heat or friction to slow down. Okay, so they're nice and narrow. And they're built that way. They're built for this lab. So watch closely the behavior of the car, specifically, well, I'm not going to tell you this, the behavior of the car. Okay.
That was 1 book high. That was the height.
So now we are going to add 2 books high, 3 books high, 4 books high, and 5 books high. We will do all 5 ramp heights, but just so you can see the effect of if we make the ramp higher, what effect does it have on the car, we're going to go ahead and we're going to, this is what you would have been doing in school, you have to make the adjustment a little bit. Okay,
There you go.
so now we have the same exact scenario, the same racetrack, the same ramp, and the same car, but we raised the ramp by 5 books high. We will actually do a ramp at 1 book high, a ramp at 2 books high, a ramp at 3 books high, a ramp at 4 books high, and a ramp at 5 books high. But we just want to show you the effect of the lowest ramp, what effect it has on the car, and the highest ramp, what effect it has on the behavior of the car. Ready? Okay. So what we're going to do is pause the video so that we can have a discussion about how ramp height affects the behavior of the car. All right?
Okay. So now, Ms. Soyka, we're going to start our actual trials, and we are going to start that with 1 book high and no cargo. So once again, the height of the ramp, a thing that we are changing in this experiment, one of the things is the height of the ramp one book high. The other thing that we are changing in this experiment is cargo. So there's either you have cargo or no cargo. So this trial is one book high, no cargo.
So we're gonna stay 6 feet apart. We're going to have an empty cargo car. We have to park the car onto the ramp. We're gonna line it up at the starting line of our racetrack. We're gonna allow the car to fall freely. And it pushed the block.
So you see there was a collision, and the block, which was initially at the start of the racetrack, has now moved. So we need to measure by how much this car, the parked car, was pushed by our trial car. So to measure that, this block actually has moved nice and evenly, so it's straight, but I want to make sure I get an accurate measurement, which I can't by just eyeballing this. So I'm going to take a straight edge, and then I have two options now. I can either measure it from the front of the car, and I can measure it from the back of the car. Which one do you think I should do? I hope you said the back of the car, right? Because the back of the car was what was touching the 0 mark on the ruler. So if you measure the front of the car was probably at like 12 centimeters. So you're measuring it starting at 12 centimeters, which is not what we want. We want it from the start of the racetrack, so it's the back of the car. So when I put the straight edge along the back of the car, I can see that the measurement is actually just less than 9. So I'm going to say that is 8.9 centimeters. So our car pushed the parked car by 8.9 centimeters. I'm going to make a note that trial 1 with 1 block high and no cargo was 8.9 centimeters. Okay.
Right, so we're gonna give Miss T a chance to set her camera up. While she's doing that, I'm gonna put the cargo in the car. We're gonna do the trial all over again. The car will be 1 book high. The ramp will be 1 book high, and it's the same car. However, we're making it heavier by adding 500 grams of cargo. So remember to stop the car. Okay. If it accidentally keeps going. Did you see that little pop? That's a mistrial. We know that by the car popping, that it forced the car to slow down. So we really didn't have the car at a true speed, so we're gonna have to do a retrial.
Yeah.
This is something that you would have done in your classrooms when you do your trial. So we just need to, what Miss B is doing right now is she's feeling with her finger to see if it's a nice level.
Not yet, Ms. Soyson. It needs to go a little more like that.
A little bit more down. Okay. Am I going in the wrong direction? Okay.
Okay, that's better.
Is that perfect or?
Yeah, that's perfect now. So I'm not even going to measure that trial because it was a missed trial. So we're going to put the parked car back at the start of the racetrack, and we're going to go, okay. Okay, so once again, I'm going to measure from the back, nice and straight, and that measurement was 23.4 centimeters. So without any cargo, that was 8.9 centimeters. With cargo, the car got pushed 23.4 centimeters. So it looks like the cargo made quite a difference. Ms. Oysen, can I put it back to the start? Okay.
And as you can see, I was quietly setting up for the next trial. Oh, wait, actually what we're gonna do is, we were at 1 book high. We're actually gonna do 5 trials with an empty car. We don't wanna just do the 1 trial that Miss B did and call it a day, right? We're gonna do it 4 more times. So when the car was empty and it pushed the parked car, we measured how far the parked car was pushed. We were gonna actually do that 4 more times. So we're doing a total of 5 trials when the ramp is raised by 1 book and the car is empty. Then we're going to put cargo in the car while the ramp is raised by 1 book, and we're gonna do 5 trials to see how far the the parked car got pushed after the collision. And that would be a total of 10 trials, right? So now we are going to add a second book. So we are elevating the ramp. It's now 2 books high.
So what we're gonna do, those 10 trials that Ms. Soyson just spoke about, Ms. Soyson and I will do those trials after we stop the video, and we'll give you just the data, because we don't want this to be a very long video, because that's a lot of trials.
Normally you're in class for an hour and a half and you would be doing this. Okay, so now we're going back to an empty car. The parked car is parked, and we are going to release it at a height of 2 books high.
Very
And we're
good.
gonna measure the distance. The cup gets pushed, I'm sorry, not the cup, sorry, the block.
Okay, so that was 2 books high, no cargo, 19.5 centimeters.
Then I'm gonna add the cargo, oh, well, wait. We're gonna actually do 4 more trials like that, right? We're gonna do 4 more trials with the empty car hitting the parked car, and we will look at those 5 distances the block was pushed. Then we will do 5 trials like this. We're gonna add the cargo, the 500 grams. Are you ready?
Ooh, excellent. So, with 2 books high and with cargo, this was pushed 30 something, let me be sure. 33.7 centimeters. So I'm gonna readjust that and make sure I write down my data.
As she's doing that, I'm adding the 3rd book. So now we're making the ramp 3 books high.
Okay, and the remaining 4 trials of 2 books high with cargo, we will do after the video and give you the data. So just a reminder, all of these things we're showing you one time. Ms. Soyson and I are gonna do it 4 more times with each of these setups. Remember that.
So now it's 3 books high, empty cargo. Ready?
Okay, so 3 books high, empty cargo. $27.2.
And then I'm gonna go ahead and put it back to the starting point. Always making sure we put the parked car the same spot each time. That's good lab technique. We're gonna let the car go. Notice I added cargo that time.
Very good.
She's gonna measure how far the block got pushed as I add.
Okay, that is 45.2.
And Miss B, can I ask you why you're stopping the car?
Oh, good
From
question.
going
Because if
again?
I don't stop the car is gonna keep pushing the block, right? So we don't wanna see, every block then will just go off the racetrack. We wanna see with just one collision, the second there's an impact, with that one collision, how far the parked car moved. So what I'm trying to do the best I can is the second the 2 cars touch, stop the first car and see with just that initial contact, how far this parked car moves.
Good question. So what we're going to do now is we raised the ramp by 4 books, empty car, about to crash into or collide with the parked car.
Perfect.
She's going to take a measurement as I add the cargo.
Okay, that is 36.3. So that was Ms. Soyson 4 books, and that was no cargo, right?
Correct.
Okay.
We have to do 4 more trials like that.
36.
4 more trials with 4 books, 0 cargo, empty car. And then now we're back to a ramp that is 4 books high, but now we've added the cargo. We're at 500 extra grams. The car is at 500 extra grams. And go.
Okay. Wow, this went pretty far, almost 60. 59.9 centimeters. 36 versus 59. So the cargo, Ms. Soyson, I can see, is really powerful in pushing this block. Okay, 5 books. 5 books, no cargo. Okay, so 5 Cooks no cargo is 51.0 centimeters.
Now I added the cargo. The ramp is 5 books high, and here we go.
Whoa, look at that.
And we're not going to be happy with just this one trial, right? We're going to do 4 more like that. You need to think about why we're doing multiple trials for each ramp height and why we're doing multiple trials for an empty car versus a car filled with cargo, okay?
Ms. Soyson, that was 79.7 centimeters. Okay.
Wow. So I just want to remind all of you that if we start with the ramp at 1 book high and we do 5 trials with an empty car and then 5 trials with a car filled with cargo, that's 10 trials at just 1 height. If we do 10 trials for 5 different heights, how many trials is that? 50! So this is why you need the entire block, the hour and a half of science class to run all the labs. We're going to stop the video in a moment. We're going to do all 50 trials for real. And then tonight for homework, we will post and reveal the results of all 50 trials. Peace out.